So here we are presenting our work on the robustness of large multimodal models against image adversarial attacks. So quick background on large multimodal models. They are typically built on large language models, but extended to image domain by combining an additional vision encoder, such as CLIP, and then a modality fusion layer, such as a simple linear layer in Lava or a Q-former in InstructBlip, followed by an instruction tuning training procedure. So because of their highly similar architectures and the shared use of backbone such as CLIP or Llama, they are highly susceptible to adversarial attack. So in this work, we want to investigate, are LMMs robust against image adversarial attacks? If not, how much do their performance degrade and in which way? And we want to provide a systematic study on how LMM performance drop against image adversarial attack quantitatively. So we evaluate on different setups, including different tasks like image classification, caption retrieval, and VQA, and different attacks and different models. And we also adopt two attack settings. One is for normal, and one is for a very strong attack. And here's the attack and evaluation procedure. So now let's look at experiments. For image classification, we conduct study on two fine-grained dataset for Food 101 and Stanford cars, and Cocoa dataset. We can see that LMM accuracy dropped similar to how much their vision encoder dropped. So at this point, we can say that LMM doesn't inherit additional robustness against vision adversarial attack more than their underlying vision encoders. And similar for transfer attack, although the direct transfer attack is not very strong, but we can still observe that LMM accuracy is directly linked to their vision encoders accuracy drop. So that again confirms the previous point. And similar for caption retrieval, we can see that so the first two sections are the accuracy drop on their corresponding vision encoders, and the third section is the LMM's accuracy drop for caption retrieval. So we can see that the drops for LMMs are similar to the drops for their corresponding vision encoders. So in these two tasks, we can conclude that LMMs have little to no robustness against image adversarial attack, even though this adversarial perturbation is not optimized end-to-end. Now let's look at visual question answering, or VQA. Interestingly, we can see that although the visual encoder's accuracy dropped almost 100% for all the tasks, their LMM's accuracy dropped very little compared to their vision encoder's accuracy drop. Similarly, we can observe that qualitatively. So we can see that although the LMM completely misunderstands the image with the adversarial perturbation, it can still answer some of the follow-up questions correctly. So why is that? By looking at VQA question type, we can see that the most accuracy drop comes from questions that are asking what. You can see the consistent pattern across all the models we evaluated here. And that leads to the second takeaway. Visual attacks are less effective when the VQA question query involves different visual contents from what is being attacked. So in other words, the attack surface is much larger than the traditional image classification-based adversarial attack. And third, we investigate how the LMM can behave when we provide additional context. when dealing with adversarial attack. And we can see that by decomposing query into multiple existential questions, each with the corresponding synthetic context, we can notably improve the accuracy, or we can notably reduce the accuracy drop against image adversarial attack. So this leads to the third and final takeaway. Adding additional textual context notably improve LLM's robustness against visual adversarial input. And we can view this similar to a form of chain of thought, which is actually utilizing the under the hood LLM's reasoning ability instead of directly improving the robustness against adversarial noise. But in any case, this in a degree improve the robustness of LLMs. That's all we want to present. Thank you.